Hello everyone, in today's video we're going to take a look at an example using parametric equations. Okay, so the example we're going to take a look at, we have x, which is a function of t, is 4t plus 3, and y, which is also a function of t, is 4t plus 8 plus 5 divided by 2t. And our t cannot be 0. Okay, so our job is to find dy dx at the point. Just pick some point, let's say t equals 2, and b, I think I'm just going to say find the explicit form, so find y in terms of x. Okay, so let's begin. Solution. Okay, so for all of these problems, let's just have a quick chat about what parametric means. We're given an x, and this is going to depend on some t, and we're given a y, and this is going to depend on some t. You let t vary, and you get different values of x and y, and it's going to sketch out some curve. And it's not written in the usual format, so we need some ideas to analyze things like how it changes and that kind of thing. Okay, so part A, find dy dx. Well, there's a nice rule for this. Dy dx is the same as dy by dt divided by dx by dt. Okay, and we've got x and y's, and they're both in terms of t, so we can jump straight in to some differentiation. So let's start with the top. Differentiate y with respect to t, so we just want to differentiate these things. Okay, so some simple differentiation, relatively simple anyway. 4t differentiates to 4, 8 differentiates to 0, and we need to rewrite this term here as 5 over 2, t to the minus 1. If we differentiate this, we get minus 5 over 2, t to the power minus 2. Okay, and on the bottom, we need to differentiate x with respect to t. So we need to differentiate this one. Okay, so this one looks a bit more simple. First term, 4t differentiates to 4, and 3 differentiates to 0. Okay, so we need to simplify this a little bit. So the top is 4 take away 5 over 2, and maybe I'll put the t back underneath. 1 over t squared, all divided by 4. Okay, I think we should, let me see, I think we can just jump straight in here. We could simplify more, but we don't need to at this stage. Let's just say t equals 2, so dy by dx is, well, substitute in 5 over 2 times 1 over 2 squared, all divided by 4. Okay, so we need a calculator for this one. I think we can just about manage. 4 take away 5/8, all divided by 4. Okay, a little bit of playing around. Put an 8 on the bottom. 4 times it all by a quarter. Get 27 over 32. If you're not convinced by that, just pop it in the calculator. So that's part A. That's the general process for finding dy dx. It's always going to be in terms of t over here. And then pick any value at t and whatever the question says and put it in. So we can sub this in. Okay, so part B. Part B says find y in terms of x. So let's do that next. Okay, well, we know y in terms of t, so let's write that again. It was 4t plus 8 plus 5 over 2 t to the minus 1. And we want to eliminate these t's. We want to remove them. Well, if we look at the other piece of information, which is 4x plus 3 is the same as, 4t plus 3 is the same as x. Well, we could write this in terms of t. This is just x. Write that a bit clearer. It's x. Oh, software doesn't like that. X, take away 3 divided by 4. And what we're going to do is substitute this into here and here. And everything on this right hand side will then be in terms of x. Okay, so let's do it. So 4t is for x take away 3 all over 4. Second term is 8. Third term is 5 over 2 times 1 over t. Okay, t is x over 3. So x take away 3 all over 4. Okay, so now just dealing with some algebraic fractions. These 4's cancel in the first term, giving x take away 3. We have 8 in the next term. Okay, this term, I think I'm going to do it a bit slow. I'm in no rush. So if I simplify the fraction here, the 4 will jump to the top and the x take away 3 on the bottom. A little bit of cancellation there. Okay, so we have x, well, the minus 3 plus 8 is 5. We have 5 times 2 is 10. And on the bottom, x take away 3. Okay, so this is quite a nice form to leave it in. I think it's quite useful if you're sketching some graphs. It's particularly looking for certain features. We could do a bit more. So I just want to say at this stage, this is fine for a final answer. But I think I'm going to go a bit further just to cover all the different bases. So let's write this as a single fraction. Okay, so how do we do that? Well, I need a common denominator. That's x take away 3. Build my algebraic fraction. Like so. So that's just like that. Got a common denominator, wrote it as a single fraction. Okay, so now I'm just going to times all this out. On the top, I'm going to need a clean page. So let's do it. Let's do a side working actually. So if we times this one out, we have x squared, 5 take away 3, so we have 2x take away 15. Okay, so when we add on the 10, that's going to change to minus 5. So our final answer, let's put on a clean page, is y equals x squared plus 2x take away 5, all divided by x take away 3. And we should highlight here that x cannot be 3, otherwise we end up dividing by 0. And there you go.